could appear in various combinations. Okay? So we have here actually some, say, damping, so that is like cafe, but free vibrations like latte, totally different things. So we are having different concepts together. Yes, sometimes people may get confused. Sometimes people do not get confused because they don't know what they are doing. So they don't get confused. So when you don't know, then it's very difficult to get confused. Just even don't know what you're doing. I should not say you. I should say we. When we don't know, then we get confused. That is very nice. We don't get confused because we don't know what to care about this, not to care. What is this? Why do I need this? We don't know this. So we are happy. So there is expression indeed, gathering knowledge, gathering sorrow. So more you know, more. So because you have much information, and I mean, probability of dissatisfaction increases naturally. But we are here naturally not just to, we would like to open our horizons to know more in order to be able to learn about nature more. And nature has this damping. So we cannot just say, okay, I will live in a undamped vibration mode. That's enough. Enough for me. Person could say, I will attend only the beginning of the class, in every class. So for example, I don't need to work. My grandfather gave me a check when he passed away, so I don't need to study. So I will take in every course 3 lectures. And I will study, something. So in my course, you would be ending, to know only 3 undamped vibrations and nothing else. Then in statics, you would know that things are absolutely rigid only, and then you don't know anything else, etc. So you will have, such a person will have very little appreciation because connections cannot be made. You just learn very little, extremely little. Okay, he will be happy. Okay, thank you, Grandpa. Okay, so now we are x of t. We are looking for the solution. X of t equals a in power st. S is a characteristic exponent, or like in usually in differential equation courses, we are looking for a in power rt. Okay, here I wrote it a in power st. So I differentiate this guy 2 times. I get s squared times a in power st. Then I differentiate this once. I get a in power st and then s. And here omega 0 squared. And then I cancel by a in power st. I get this. This is called characteristic equation. What we obtained is called characteristic equation. This S, what I wrote, is not arbitrary. It cannot be anything. You cannot say, what is S? Oh, put what you want. No, S cannot be anything you want. S should satisfy this quadratic equation. S squared plus 2 zeta omega sub 0 S plus omega 0 squared equals 0. So again, zeta is a damping coefficient. Omega sub 0 is undamping, so to say, characteristic. It's a free. Okay, I solve this, and I get S12 equals minus Z omega sub 0. Okay, I should write this, actually. I should write this. So when I solve this, I get S12 equals minus 2 zeta omega sub 0 plus minus 4 zeta square omega 0 squared minus 4 times omega 0 squared. Say it again?
Quadratic equation roots?
Yes, quadratic equations root. Yes, yes, you are right. So then I get S12 equals minus 2 zeta plus minus, there is 4 here and 4 here, I get it 2. Zeta squared omega sub 0 squared minus omega sub 0 squared divided by 2. And these 2's are cancelled. And I will get S12 equals minus zeta plus, so that is how we write zeta. Look, please follow mine. Okay. So minus zeta plus minus, then omega sub 0 gets out here. Omega sub 0, zeta square minus 1. But there is omega sub 0 here. And omega sub 0 here. So this S12 equals minus zeta omega sub 0 plus, okay, that is the final expression. Minus zeta plus minus square root zeta square minus 1 omega sub 0. Okay, now we have to deal with various cases of zeta. So zeta is damping coefficient. So if there is no damping, so that is very important because we would like to relate what we had before. Before we had no damping. So we would like to see, are we correlating with what we had before or we just, are on the new ship? So zeta equals 0. So this guy is 0. This guy is 0, so then it is minus 1. So I get plus minus I. We have purely imaginary roots leading to harmonic solution. When we have plus minus I omega, I here, I omega, then I will have here, look please, E in power I omega and E in power minus I omega. So according to Euler's equation, then it gives cosine omega t sine omega t. So that means that it's okay. That is what we had before. Now there are other cases. Pay attention that our notation was very beautiful. Why our notation? This notation, 2 zeta omega sub 0. First of all, this 2, because I had this 2, suddenly there is no 2, no half, no nothing here. Because of this 2, this expression is, look, do you remember when we have these 2's and there is 1/2 here, yes, 1/2. I divide by 2. Because I divide by 2 and there was 2 zeta here, then this 2 disappeared in the final expression. Okay, again, because in front of s squared there is nothing, there is 1, so I have to divide by 2 in quadratic equation. Especially for this case, I wanted second coefficient, or we wanted, so we want to have second equation be having 2 there. Because then at the end, these 2's will cancel. And then we will have something without 2, without 3, without anything. So that is what we have. So first of all, there is this very simple expression. Minus zeta plus minus zeta square minus 1, omega sub 0. Okay, first of all, when zeta equals 0, we know there is purely harmonic solutions. Now there are many cases here. There are 2 other cases. Or zeta square is greater than 1, or zeta square smaller than 1. Okay, so these are the 2 cases. Now, what is zeta square bigger than 1? Zeta square bigger than 1 means damping coefficient is bigger than 1. So that means there is big damping. Zeta greater than 1 is big damping. Zeta smaller than 1 is small damping.
Zeta square or just zeta?
I will look. zeta square bigger than 1 is bigger damping. Zeta square smaller than 1 is small damping. Now there is a particular case. Also, we can say also for zeta because 1 squared is 1. So zeta equals 1 is a critical damping. Zeta equals 1 is a critical value. When zeta equals 1, this term disappears, and we have two coinciding roots. We have S12 equals minus zeta. But this minus zeta equals 1. So we have S12 equals minus 1. When zeta equals 1, these two roots coincide with minus 1. So we suddenly see that this zeta equals 1 is an important milestone, so to say, in our discussion. Okay, for zeta equals from 0 to 1. Now, from zeta from 0 to 1 means small damping. This is a small damping. Okay, from 0 to 1. Now, this is most, so to say, mostly found case, because there is small damping. There is not a big damping. So there is some small damping in the system. Then complex roots, S1 and S2 are complex conjugates. Why they are complex conjugates? Because we had zeta square minus 1. For zeta greater, going to infinity, say very big, okay, then zeta square minus 1 is approximately zeta, because this is much bigger than 1 for very big zeta. Okay? So then we have S1 goes to minus zeta plus zeta square minus 1. So this goes to zeta, minus zeta plus zeta, this goes to 0 for big damping. For now S2 goes minus zeta, so it goes to minus 2 zeta, but zeta goes to infinity, so it goes to minus infinity for big zeta. So I considered actually up to now 3 cases. Zeta equals 0, purely imaginary roots. Zeta between 0 to 1, complex conjugates. And zeta very big, then S1 and S2 are, say, real numbers. This goes to 0, this goes to minus infinity if it is very big. But we don't need just this big to consider big values and very small values. We need also to consider any values. Okay, any values, general solution is written like this: A1 times e in power S1t plus A2 e in power S2t. I would have loved, to skip derivations and give you a final result, but that is like to invite you at a party and you did not participate in preparation of the food, and then you actually do not appreciate maybe that much labor was put there, that it was made with love, that it was, we were sweating and we enjoyed, etc. So therefore, I will have to give you all these details. By the way, I also recommend you from time to time, when you are inviting guests at home, that you cook together. You will enjoy much more. Okay, so then we will get this. Now I have to just substitute. X means E in power. Because I have difficulties of writing E and then very big expressions on the top. Therefore, I just wrote exponent. A1 exponent minus zeta plus zeta square minus 1, close parenthesis, omega sub 0 t, plus A2, then minus here. Plus here, minus here. Okay? Please write this very first line. And actually, the situation is the same like with food preparation. At the end, when you prepare beautiful food and guests say, oh, that was very tasty, you get the satisfaction. But you have to work hard for this. We have to work hard. So we will, it's not hard work, actually it will be very easy, but still it takes some time. It may seem a bit boring. Why do I need all these steps? But without these steps, actually the final result is not that interesting otherwise maybe. Okay, so what I can do is there is this E, there is a summation, and here is also summation. This term here, minus psi, minus zeta omega sub 0 t, and minus zeta omega sub 0 t is the same in both expressions. So therefore, I can take it out and put it here, e in power minus zeta omega 0 t. And what will be left inside will be a1 exponent with positive power plus a2 exponent negative power. Okay, so then we have this one. Yes, I took this out. Now this representation is good when zeta is bigger or equal than 1, because there is exponent. So this is real, and everything is real. Suitable for cases in which zeta is greater than 1. For zeta greater than 1, motion is aperiodic or non-periodic. Because look, there is something rising and something decaying. One term rises, another term decays, so together there is some, I will show you a figure. Okay? When time goes to infinity, that decays this expression. So this zeta greater than 1 is called overdamped case. Overdamped. What does it mean overdamped? It is bigger than 1. Overdamped means bigger than 1. Zeta is greater than 1. It's actually over 1, if you want. Over 1 damped case or something like that. I mean, if you want to be very exact. Because all the cases are damped. If there is zeta, that means there is damping. Overdamped means greater than 1. That is a slang, so to say, between us. So this is a representation. Now you may ask, come on, we did not finish the story. I have x of t. How to find a1 and a2? Oh, a1 and n2 should be found from initial conditions. I should give you, no, initial position and initial velocity, and then we will find x of t. How to find a1 and a2? a1 and a2 can be found from initial conditions. It's very simple. Like before, like we did before. Naturally, analysis is longer. Now, for x dot, then I have to differentiate this, etc. But everything is straightforward. Nothing special, nothing difficult. How do figures look like? So that is important to bring like this. I don't remember from which book I took it. In undergraduate courses, I usually use textbook. And sometimes textbooks are very, very good, and I'm going exactly according to that text. Sometimes textbook is not as good, and we are deviating and adding things from other sources. So here, vibrations, there is ocean of books in vibrations. So there is possibility to pick and choose, but still they are thick books. So I don't like usually thick things because too much. Publishers like book to be heavy. I don't know why. I cannot understand why publishers love books to be heavy. Okay, so here what I'm giving you is a smaller version. So it would be, say, half of the thinnest book available, what I give you. So that would be enough. If there was a book which is half the thickness that is of the thinnest book, then I would have adopted it and I would have gone with it. But people have this desire to save too much. Okay, or much too much. Now, what happens when zeta equals 1? Zeta equals 1.
Second expression is eliminated as one.
Say it again.
Second expression is eliminated as one.
A student says that second expression is what?
No, when delta is equal to 1, in this equation, it's just...
Yes, yes. In the second equation here, when I will substitute, student is right. He says, in this expression, that is what I wanted to say, and he said it before me. In this expression, minus zeta plus minus zeta square minus 1, this term is falling down. I get minus zeta omega sub 0, and this zeta equals 1, so it's minus omega sub 0. So this is called critical damping case. Now, what does it mean, critical damping case? Zeta equals c divided by 2m omega sub 0.
Natural frequency.
Yeah. Zeta equals 1 means, look please, this equals 1 means c equals to what is written here. So this is c critical. That is a critical value of c. C critical equals 2m omega sub 0, or 2m square root k over m. It equals 2 square root km. When c happens to be equal square root of spring constant times mass, then this is a critical damping. So then this C, so C can be any number actually. Theoretically speaking, we can have system with any C. So there is one particular, what is important is whether that C is bigger than this value or smaller than this value or equals to this value. So this is a borderline between the cases in which zeta is greater than 0 and zeta is smaller than 0. That is a border case. So paying attention to differential equations, and first of all, on one hand, using solution of differential equations on one hand, and on the other hand, convenient notations, suddenly brought us to new world, of concepts. There are three things. overdamped systems, critically damped systems, and this is called underdamped systems, zeta between 0 to 1, underdamped systems. Now, another interesting observation. Yes, here C critical we did express in terms of natural frequency of look, damping critical coefficient is connected here with undamped natural frequency. Yes, that is correct. But once I substitute the value, I just get it also 2 times Km. So there are 3 coefficients there, C, K, and M. So if C happens to be 2 times square root of Km, then this is a border case. So actually there is no paradox of damping and undamped vibrations. Once I substitute here, I have removed any paradoxical consideration. This is just numbers, 2 numbers, K and M. I have 3 numbers, C, K, and M. When C happens to be this one, then this zeta equals 1. When C is smaller, then it is underdamped case. When it is bigger, then it is overdamped case. We used very convenient notations, but at the very end, we don't need, so to say, we can substitute everything, and then we are getting rid of omega sub 0. Omega sub 0 is like a car that brings you from your home to FAU. But then you put it in the garage or on the parking lot or somewhere where you are forbidden to park, and then you get a ticket or something like that. Any questions? Okay, if there are no questions, then we will finish today, and today I will not give you homework. Today is Wednesday, I think. So we do not meet coming Monday, because coming Monday is Martin Luther King's Day. So you may want to think about one expression that I like very much of his, and that is like this: injustice anywhere creates injustice everywhere. Thank you very much. Strange, yes, on Wednesday to say happy